Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
I feel like a lot of my geometry videos have been kind of leading up to this point about side angle side and side congruence. So the first thing I want to do is I just want to prove what we've got going on here, okay? Now, what you'll notice is that I have two sides marked with congruency. AC is marked as being congruent to XZ, and BC is congruent as being marked the same as YZ. And then they both have one angle congruent. Angle C is congruent to angle Z. And that's all we know about these triangles. We don't know anything else. There's one side we know nothing about and two angles that we know nothing about. So what does that mean about triangles and congruence? So what we're going to do is the first thing is we're going to redraw these triangles to where they're touching. Okay, so basically I just kind of want to close the gap. Okay, so that might mean rotating it a little. Okay, so I'm going to kind of make BC be vertical, which means A is going to come over to here. Let me fix that. And then I'm going to also draw YZ vertical, and then X will come over to here. Now remember, in the original, we said that angle C and angle Z were the same size. And we said that these were the same size, which is why we were able to match them up. And then we said these were the same size. Now let's think what's happening here. If I were to fold along this line right here where I match those two triangles up, do you see how they would line up perfectly? So because that would act as a line of reflection, that tells us everything on the left is the same exact size as everything on the right. Thus, this would prove these two triangles are congruent size. Because if we smashed them together and lined them up on that one matching side, we'd have that perfect reflection. Everything would match up. So anytime you're given two congruent triangles where they've marked these three pieces of information, you're going to be able to do this, okay? And it just has to do with you slide them together, you make them share a side where that angle's matching up at the right spot, and you're able to fold. So what does that really look like anytime you're given? Okay, so if you are given two random triangles, and I'm drawing them somewhat the same, hopefully I drew them the same, I'm guesstimating, and they gave you this for a side, this for the angle, and then this for another side, we could go back through this entire process of let's take this one, might have to reflect it to be able to get it to line up, right? That's okay, that's still a rigid transformation. And we would be able to say that no matter what, these two triangles are congruent because of side angle side. And again, it's side angle side, so we could do pink, blue, purple, or we could do purple, blue, pink. I don't care which way it goes, but the angle has to be connecting the two sides. This is known as an included angle, and that's because the angle is between the two sides. Okay, so this would be a way to prove triangles are congruent by side, angle, side. And we don't like writing side, angle, side a lot, so we have just abbreviated it SAS. I had one student that just liked to say, hey, SAS. Oh, my triangles got sassy. I know they're congruent. Okay? So anytime you're given information about side, angle, side, it tells you the triangles are congruent. And then once the triangles are congruent, you know everything not labeled as congruent as well. Then you know, hey, this angle is the same as that angle. And this angle is congruent to that angle. And this side, oh yeah, is congruent to that side. So because you started off with these 3 pairs of congruencies, now we've gained the other 3 pairs of congruencies. And so once you get a little bit, you actually got a lot. Okay, so let's go ahead and let's just look at what that would be. Let's say I told you triangle ABC is congruent to triangle XYZ. Okay, if the triangles are congruent, all of their corresponding parts are congruent. Okay? So if the triangles match up, their corresponding parts match up. Okay, so angle A would be congruent to angle X because the order matters. Angle B would be congruent to angle Y. And angle C would be congruent to angle Z. Therefore, side AB, BC, and AC, we'd have 3 sides from the first triangle, would be congruent to XY, BC, so YZ, ooh, congruent, not equal, and XZ. Okay, so when I listed out that the 3 pairs of angles would be congruent and the 3 pairs of sides would be congruent, I was talking about all the corresponding parts of the congruent triangles are therefore congruent. And that's a mouthful. So we shorten that in math class to CPCTC. So I know a lot of students get all the C's mixed up and things like that. So just think every other letter is a C. Or corresponding parts congruent triangles are congruent. If you say that in your mind every time you write it, you will get more comfortable with what it is and what it means. It's a very big part of geometry and we will use it a lot. So we have to start in on the proofs. That's the whole point of this. And so let's just jump into it. Okay, so here we have a picture and they've given us some information. So any good proof is we're just going to go ahead and we're going to write things down. I like to color code and I like to highlight. So first thing I'm going to do is I'm going to just make a very light sketch over to the side of my shape so that I can go over it with colors as we go. So A, B, C, D, and we have that. Okay. So my given is written in black, so the first thing I'm going to do is I'm going to write AB parallel to CD, AB congruent to CD. And statement 1 is written because it's given. All right. Now, the parallel I'm going to mark in orange. Okay, it doesn't give me much, but parallel happens. However, the congruent, I'm going to go ahead and draw that green line. What we're hoping for here is, since it's new to us and we can use it, we just talked about side, angle, side. So right now I have side. But the parallel has to be giving us something. So what happens when we have parallel lines cut by a transversal? Okay. Well, when we have parallel lines cut by a transversal, think about that transversal right here. it creates congruent sides, or congruent angles, right? So because of that, this angle right here is inside the parallel lines and on the alternate side from this angle right here. So we can say the measure of angle BAC is congruent to the measure of angle DCA. And the reason for that is alternate interior angles. So anytime they tell you you have parallel lines, start looking for the transversal. What connected the parallel lines? How is that going to help me? So now I'm starting to see like a couple triangles here, right? I have side, angle. I'm supposed to get the other side. The side that I'm supposed to get is the other piece, the other side of that angle, so that the angle's in between my two known pieces. That way my angle's in between my two known pieces. Now what I just marked in blue is that transversal, right? Ah, don't they share that side? Yeah, they share that side. So anything is equal to itself. So on 3, we're going to say AC is congruent to CA. And see how I wrote them backwards? Yeah, so that's that reflexive property. Okay, so I marked this in green. So I have green, purple, blue, green, purple, blue. I have side, angle, side because I have to go green, purple, blue. Okay, so line 4, triangle. Okay, we're going to go from B to A, green, purple, blue, is congruent to triangle. Remember, we need to go down the green side, then to the purple angle, so DCA. Okay, so that was green, purple, blue. Whoops, that was supposed to be C, wasn't it? Okay. And that's a D, not a B. I'm having a case of the I can't read my own writings today. Don't do that. Okay, so BAC is congruent to DCA. We have congruent triangles, and our reason for that is side, angle, side. Our triangle got sassy. We marked the side, we marked the angle, and we marked the side in that order. So the good news is because triangle BAC is congruent to triangle DCA, all of the corresponding parts of the congruent triangles are congruent. And isn't B in the same location as D now? See, starts with B, starts with D? Absolutely. So now we can say angle B is congruent to angle D. And the reason we can say that is the corresponding parts of congruent triangles is congruent. Oh, that is a lot of words, which is why we abbreviate. We don't want to write side, angle, side. We want to write SAS. We don't want to write corresponding parts congruent triangles are congruent. We're going to write CPCTC. If you are a person who says CPCTC every single time, you're going to forget what it means. Corresponding parts congruent triangles are congruent. So I did start off this video the saying we weren't just going to do side, angle, side. So I'm going to kind of go over this one here a little bit quicker. Okay, A, B, C, J, KL. I'm going to mark A with a purple, AB with purple, and JK with purple. I'm going to mark BC with blue and KL blue. And I'm going to mark AC with orange. Okay, so these two triangles are drawn such that all their sides are the exact same length, which means if you were to trace this one and rotate it around on top of this one, they would line up perfectly. Or, assuming that I actually drew them correctly instead of just randomly drawing them, we'll assume that I actually did a great job drawing them, which, again, I am not the artist, so please forgive me. I just freehand sometimes, and sometimes it looks a bit wonky. But if you truly have two triangles with the same exact 3 lengths of sides, those triangles are going to have to match up perfectly. There's no way, and you could line them up to where they shared the side length that was matching and then do the reflection thing like I did with the isosceles triangle, or sorry, the side angle side triangle. And so you're going to actually find out that because we've labeled all 3 sides as being congruent, that this is going to cause triangle ABC to be congruent. Now I went 1, 2, 3, so I got to go 1, 2, 3. Order matters. So between the one line, I either have to start with J or K, but my next one is going to be the 2 lines, so I'm going to start with J. Triangle JKL. They're not always going to be alphabetical, okay? But in this case, it's by side, side, side. So now that you're given those 2 rules, if they give you information about triangles, look for side angle side or look for side side side. Because if you have those 3 pieces of information, that's enough to say, hey, these triangles are congruent. And once you say the triangles are congruent, you can say that their corresponding parts of the congruent triangles are also congruent. So you have to choose one of those 2. I haven't discussed any more yet on this video, I will. One of those 2 to be able to prove triangle congruence. Now, it has to be the included angle, okay? It cannot be side, side angle, okay? SSA does not work, and it doesn't work in reverse either for everybody thinking they're cute. It does not work. It does not prove congruency. And here, let me show you why. Okay. Side, side, angle. Okay. I need my compass to prove this one because I don't want to let you down here. So I want to make sure that I copy this side perfect. Okay, I'm going to draw a second triangle inside of it. Okay. I think we can all agree that this angle occurs in the big triangle and the shaded triangle. I'm going to draw them separately here as well. Okay, so that would be the angle. And I think we can all agree that both the big triangle and the little triangle share this side. And I think you all saw me take this side and copy it to where it was that side. Okay, so this time I've drawn my picture to where my angle is not included. My angle is not sandwiched between these two like it was in side angle side. Instead, it's out to the edge. So remember again, in side angle side, it was side, angle, side, side, angle, side. That angle was in between the two marked. Here, in between the two marked would be up in this corner, and we can definitely tell that those are not the same size. So side, side, angle, side, side, angle, or angle, side, side in reverse, is not going to prove that two triangles are the same size. So when doing this, you have to make sure that it is your two sides with the included angle, not the outside angle. It has to be the included angle, and I've given you a visual here why side, side angle does not work. Now, when you do get to trigonometry class, they are going to give you information about a triangle that is side-side angle, and you're going to actually have to tell them how big both triangles are. You're going to have to find them both, but that's, a trig class level, not a geometry class level. So the reason side-side angle does not work is it could create up to two different triangles. Side angle side, good. Side-side angle, bad. So when you're working this through, make sure that that angle is in between your two sides, not outside.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.